Hello. This is part 3 going over Geometry Semester A, Unit 4, course activity, Triangle Similarity. This part is going over side criterion for similar triangles. The side criterion states that two triangles are similar if all three sides of one triangle are proportional to the corresponding sides of the other triangle. And we are going to go through this activity and we are going to determine whether or not that is true. So for part A, it asks us to create a random triangle ABC. So we could do that by clicking our polygon tool, and let's make our random triangle something like so. Okay? So it also asks us to record the length of its sides. So we could go to the measure tool, click distance and length. Then we're going to click each individual side, and that will give us the side lengths for our triangle. So we have 3.61, 6, and 3.61. Record that in part A, and then you can move on to part B. In part B, we are going to start creating our new triangle DEF. And we start that by drawing a line DE parallel to BC. So let's go ahead and find our parallel line tool, click BC, and let's drag it over here. So we have our new point D on this parallel line, but of course we need to form our side DE. So I'm going to click D using my line segment tool and create a side that is shorter than our BC because we don't want them equal or else that defeats the purpose. And now I have our side DE. Once again, I'm going to click the measure tool, and it seems we have a side of 2.81 for DE. Next, in part B, it asks us to record ratio n of the length DE to the length of BC. So we're going from our larger triangle to our smaller triangle. So in that case, we are going to uh, we're going to divide DE by our BC, and that's going to give us our ratio between those two sides. So that's going to be 2.81. Ooh, make that a little neater. 2.81 divided by 3.61. And that is going to be, let's plug that into your calculator. We have 2.81 divided by 3.61. And that's going to give us roughly 0.7783. And then it goes on for some time. And we're going to multiply this ratio by our sides, our remaining sides, that being AB and AC. Now, AB, luckily enough, is equal to BC, so our side length is going to be equal to DE. So AB is also going to be equal to 2.81. And our AC, that one we do need to plug in, so we'll multiply AC by this number, so that times 6 will give us roughly 4.6703, and then it continues on. So do make sure to record those values, but we are going to jump into part C now. And using D as a center, we are going to draw a circle with radius that is equal to uh, our n times AB. So that's going to be our new length for 3.61, which again is going to be equal to 2.81. So let's get our circle tool. Center and radius is what we want. And we are going to input a radius of 2.81. Ooh, don't have my number lock on. 2.81. Okay, we have our circle there. Now we need to use point E as a center and draw a circle that has a radius equal to length of n times CA. So let's go ahead and put that in. And that value was 4.6703601111. That should be enough. And we have our new circle there. And we're going to locate and label the points of intersection between the two circles as point F. So D, E, F is going to be right here. So our point tool is going to be the intersection here. And we're going to complete DEF by connecting those points. So our polygon tool, D, E, F. And if we have done it right, our lengths should be 2.81 and 4.67. That is of course, our new value for the side corresponding to AC, just multiplied by our ratio, which is what we got, just rounded. For part D, all it asks us to do is to record the measures of the angles of ABC and DEF. So let's see our angles. So we click our measure tool, click angles, click in the center to get our angle measurements. Likewise, we're going to do the same thing here. And they are pretty darn close. There's going to be some difference between the angles because of our rounding. But if you look, 112.62, 112.48, and the A and C match pretty close to the F and E as well, 33.78 versus 33.69. If we hadn't rounded, they would be exactly equal. So that is one of the limitations that we encounter with GeoGebra. But I'm here to tell you that they should be equal to one another. So make sure to record that for part D. And in part E, it says, using the results, draw a conclusion about the relationship between the two triangles. So our conclusion is that if we have three corresponding sides, so we have the three sides of the triangle correspond to one another, the angles are going to be equal. And if we have a triangle that has corresponding sides and equal angles, we of course know from our definition of similarity that the two triangles are going to be similar. And we're going to put something akin to that for part E. But all in all, that completes task 3.